So when we're comparing experimental and quasi-experimental designs, we can compare them in terms of the validity and generalizability. So when we're talking about internal validity, which is causal validity, true experiments generally give us more valid conclusions about causality because they're so controlled and we know there's no systematic differences between our groups, etc. But then quasi-experiments actually may provide more generalizable results because, well, we've got the true experiments are that nice controlled environment. You've got random assignment, so it's great for internal validity. But quasi-experiments may be more like the real world, and they're more likely to take environment into account in that context part. So study design then might be kind of a weighing of what's more important for research to accomplish. So we want to focus more on internal validity and causality, or do we want to focus on generalizability and being able to say that this applies in the real world? So maybe we want to try to figure out which one is more important for a given study. Although a carefully designed study of either type, either true experiment or quasi-experiment, could accomplish both of these. It's just in general, these are kind of what we find. So when we're looking specifically at internal validity, how much we can yield valid conclusions is determined by predominantly how comparable our groups are. So that's why true experiments, they're super comparable because there's no systematic differences between the groups. But when we're looking at quasi-experiments in particular, but I mean, this could happen in true experiments as well. You have 5 basic sources of invalidity, so that it's going to make it tough to talk about causality in any real way. And so these are selection bias, endogenous change, external events, contamination, and treatment misidentification. So let's briefly go through those. So selection bias basically means that the treatment and control groups are inherently different. So there is some kind of difference in how they've been selected. So the difference is not because of the treatment, which is kind of what you would hope it would be if you're actually looking at some causative effect. You would want there to be a difference between your groups, but you want that difference to be because of whatever the treatment is. So a selection bias means there's something that makes the groups differ that has nothing to do with the treatment itself. And it could happen at the beginning of the study, so before you even start, or it could happen at the end and have something to do with something else that happened. So one thing that might happen that makes a selection bias happen, that would happen kind of during or at the end of a study, is what's called differential attrition. And this means that you have this is just one type of selection bias, but where you have the groups become different because one group has a higher likelihood or a different likelihood of people dropping out than the other group. And it could be because you have more people dropping out from the control group if they find out they're in the control group. And so they're like, well, why am I going to bother staying? Because I know I'm just the control group, so I'm not actually getting any kind of benefit here. So that can happen. Versus knowing that you're getting the best treatment, and if you find that out, then you're like, oh, I'm definitely going to stay because I'm getting the best treatment available, or at least that we know of. Or it could kind of be because the treatment is actually worse, or it takes more effort to go through. So a good example of that is if you're comparing a group getting a treatment versus a group just not getting any treatment. Well, going to the treatment actually takes time and effort, and so you may have people drop out of that just because it takes more time and effort versus, well, just not going to anything. That doesn't really take time and effort. They just have to come and answer questions like once or twice. So you may have more people drop out of the treatment group because it takes more effort. So in either of those cases, it means that your groups are different for a reason that has nothing to do with the treatment itself. It's just they are leaving at different rates for some reason. Now, pretest can help with this because first of all, it can tell you if there's a selection bias right at the beginning before you do anything. So if you have a group that is just different for some reason, you can tell at the outset, and then either sort of somehow regroup people, or you can just control for that if you know it exists. So if there is something at the beginning, then pretest can help with that. But if something happens along the way, like differential attrition, that's harder to control for. Although if you know it's there, it's possible to control for it, but it makes things more difficult. And then another source of invalidity is what's called endogenous change. And this is where you have natural developments that will happen in people that's not, again, not because of the treatment, but there's some kind of something that changes people and accounts for some kind of change between the pre-test and the post-test. And so 3 specific threats to this. You've got testing, which means that there's an effect of the test itself that you're doing to gather the information about your dependent variable. So the pre-test might influence the post-test itself, you know, or if you have multiple tests along the way where you're getting them to do surveys or something like that, then, you know, the people that are in your sample, they're going to learn something and respond differently just because, oh, I've already seen this question before. Maybe I thought about it and I actually was like, oh, I should have answered that a different way. So then when they see it again, they're just going to answer it that different way just because they've seen the question before and not because of anything that has to do with the treatment. So there's the effect of the test itself that might cause a change. And then there's just natural maturation that happens. You know, people are going to respond differently because they're aging. So if it's a longitudinal study, they're older and wiser, they've learned more, they might just answer differently because of that. Maybe they've completed school, so they're more educated about something. There might be some other significant life events like getting married, having kids. Usually, though, those are only a threat in like a longitudinal study, but still it can be a threat. And then regression is another one. And this is where you're just going to sort of have what we call regression to the mean, that if over time you do enough testing, people are naturally going to regress to whatever the normal is in a group. And so people are going to look like they're changing and being different, but it's really kind of what's natural regression. And so these are all only kind of threats if they happen at different rates in the group. So if you have both groups that are, you know, going through natural maturation processes, that's fine because it's not going to show differences. But if you have one group where there's one of these changes that happens more than the other group, that's where it becomes a problem. So if there's an effect of the test, but it's happening to both groups, that's not a big deal because then you should still see a difference in your treatment group if the treatment actually did something. But if your treatment group, say, is getting more tests, and so that is affecting them more, then that might be a problem. So you want to try to make it so that this is not happening at least at a different rate in both of your groups. And another threat to internal validity is external events. And so this would be something that happens outside of the experiment that could affect the scores in some way. So something like a highly publicized school shooting might make people more fearful of crime. Maybe they'll be more retributive towards offender. Maybe they'll be more in favor of gun control, or the opposite, as happened in the U.S., more guns for teachers, which doesn't make any sense. But these external events, if they affect what you're asking them about in a survey, or if they affect something that you're measuring them on, then that, again, has nothing to do with the treatment, but it's going to cause a change. And so if you carefully control the conditions for both groups, though, this could reduce the chance of any kind of invalidation that happens. So if both groups receive the same amount of exposure, say, or some kind of debriefing about the event, or something like that to mitigate the effects, this can help alleviate the effects. But again, if it's happening, if it has a different effect on your two groups, that's going to be more problematic than if just everybody is exposed to the same material and whatnot. And another threat to internal validity is contamination. So this is where you have the control group is affected by the treatment group, or the treatment group is affected by the control group. So one of the group is affecting the other in some way. So it's contamination because you have this cross-contamination effect happening where they're changing each other's group in a way that has nothing to do with the treatment. So there's two ways that this can happen. An interesting one is what's called compensatory rivalry. And compensatory rivalry means that the control group, they find out they're part of the control group, and then they're like, well, I'm going to work harder to show that I don't need this stupid treatment. I can be just as good as the people getting the good treatment. And so they amp it up, and they're like, oh, they think they're better? Well, I'll show them. And this is actually, there's a name for this. It's called the John Henry effect. And this was sort of a specific type of compensatory rivalry. And this was where a guy literally died of overexertion trying to outperform a steam drill. And he succeeded. but he was trying so hard to show that he was better than the steam drill, and clearly not working the same he would have on like his regular job before this steam drill came in. But he did. He overexerted himself to such an extent that he actually killed himself at trying to outperform the steam drill, but he did. But that was this idea where he amped it up so much that it's clearly not a valid comparison between the groups, because that's not how he would normally work. So compensatory rivalry is a problem, because that means that they're going to specifically behave in a different way than they normally would, which isn't a good measure then of sort of that control of what happens without the treatment. And another way this could happen has the opposite effect, is demoralization. And that's where the control group, they feel cheated or left out, and so then they become worse than if there was no study at all. And it's this idea like, oh, well, why bother? Like, they clearly have the better thing and I get nothing, and so it's not fair. And so then they get those kind of demoralizing of the thoughts, and they're like, whatever, I'm just going to give up trying then, because clearly we can't win this. And so then if you get that kind of effect, then that means they're going to be worse than they were had there just been no treatment. And so that's not a good measure of no treatment either. So both of these can have an effect just by virtue of the fact that that group finds out that they're part of the control group. So either they ramp it up to try to make up for it, or they just give up totally. And either one of those can have problematic consequences. And so then you have treatment misidentification. And this is where you have the treatment itself isn't causing some kind of outcome, but it does cause some kind of intervening process. And this is only a problem if the researcher isn't aware of this process or they haven't identified this process. And basically this means that something else is happening in conjunction with the treatment, but it's not the treatment itself the way that it was originally designed. And so there's kind of three sources of treatment misidentification. The first one is if you have the expectancies of experimental staff. And this would be where you have like the staff are all excited about the treatment, and they're like, yeah, and they work like extra hard with the treatment group. They expect results from the treatment group, so they're looking for those results. And then they're just like, whatever with the control group, and they're like, I'm not even gonna look for any benefits, because we know that they're not gonna get any benefits because they didn't get the treatment. And so they're not doing that consciously, usually, but it's something that is just naturally going to affect kind of what they look for and what they observe and things like that. So the best way to deal with that is to have double-blind procedures, if possible. So that's where staff and the people who are doing the treatment and the people getting the treatment, nobody knows if they're part of the treatment or the part of the control group. So sometimes that's impossible to do, because if you're doing a whole new therapy, let's say, you're going to know if you're in the new one or the old one. But if it's possible, that double-blind procedures can help, because then if you don't know if the treatment group or the control group, then you treat the groups the same. And then there's the placebo effect, which I'm sure you've heard that, where subjects that receive a treatment they think is going to be beneficial, then they improve because of that expectation rather than the treatment itself. So this could just be, well, even if they find out they're part of the treatment group, or even if they just think they're part of the treatment group, and they think that they're getting this new thing, they're going to get better just because of that and not because of any real change that's happened. And then we have what's called the Hawthorne effect, where this is where you have the people will improve in some way because they literally just feel special for being in the treatment group. This is actually called the Hawthorne effect because it's named after a productivity experiment that happened at the Hawthorne Electric plant in Chicago. Workers were moved to a special room to study the effects of lighting intensity, and the ones who were moved to this room, they increased their output no matter what the conditions were, even when the conditions got worse. And so they made the lighting too dim or strobing almost, and they were still doing better because they're like, oh, we get this special new thing. So then they just did better because they were in the special group. So that can cause some validity issues too. So basically for any of these things, anytime a change is happening that isn't because of the treatment, that's going to cause some internal validity problems. And these are all just examples of that. But anytime it's something is different and something changes the groups in a different way, and change happens that isn't because of the treatment, it makes it difficult to impossible to know what the treatment actually did. And that's what this was.